All right, so on your homework that was due on, what was that, Friday? There was one question, I mentioned this earlier in class, the challenge question at the end that required a little bit more thinking or work. Those questions, if they're labeled as challenge, are not optional questions. I always want you to try them. You might not get them right, and that's okay, but I do want you to attempt them. And this question is similar to what was listed as your challenge question, so we're going to start there and look at different ways we could solve this. So the question says, in the 6th grade, there's a 3-to-2 boy-to-girl ratio. If there are 80 total students in the 6th grade, how many boys are there and how many girls there are? Are there, not there are. Anyways, so the first thing we need to look at is in this 3-to-2 ratio, what is the total there if there are 3 boys and 2 girls? 5. There are 5 total.
Could you
Siri. There are 5 total students, right? But the problem is asking us to figure it out when there's actually a total of 80. So the first thing we need to figure out is if our current total is 5 people, but we want the total to be 80, how many times bigger do we need to make that? 16. 5 times, essentially we're saying 5 times what gives me 80? Or 80 divided by 5 is what? And it's 16. So all we need to do is take our given ratio, 3-to-2, and make it 16 times bigger. So we're going to multiply 3 by 16 and 2 by 16, and that gives us 48 and 32. So if there are 80 total students, these two add up to 80, we would expect 48 boys and 32 girls. What we just created by doing that is essentially what's called a proportion. So a proportion is 2 ratios that are equal or equivalent to each other. So do we remember last week we talked about ratios? Ratios are used to compare 2 things. We're essentially making 2 equivalent ratios, and that's called a proportion. Okay? So if we look at your notes, this is the page I asked you to flip to in your notebook. If you look at the top section of that proportion set of notes, there are 4 different strategies we can use to create proportions or to check if 2 ratios are proportional. The good news is the first 2, all right, our first 2 strategies are actually strategies that you've used in previous years. So simplifying, think of simplifying fractions. When you simplified fractions, what did you do? I think you've done this in the past. Yeah. Allie? It's all right, we'll phone a friend. Haley?
Divide them by the same number.
Yeah. Yeah, divide them by a common, what's called a common factor, or the same number. So if I was trying to see if a 2-to-3 ratio was equivalent to 12 to 18, what goes into both 12 and 18 that I could divide those both by? Scarlett? 6. 12 divided by 6 is 2. 18 divided by 6 is 3. So that simplifies down to that given ratio of 2-to-3. Those would be what we consider proportional. They're equal. We could also look for a common multiplier. So 2 times what gives us 12 across the top? Is 3 times 6, 18. Yeah, so since I multiplied by the same thing, kind of like making equivalent fractions, those 2 ratios are equivalent. We call them proportional. Okay, so those 2 strategies work. We're going to skip cross products for a second. Converting to decimals. Does anyone know a fraction? These ratios are in fraction form. A fraction is an unsolved what kind of problem? Addition, subtraction, multiplication, or division? Division. It's an unsolved division problem. So I could divide numerator divided by denominator. So 2 divided by 3 here and 12 divided by 18 here. And if they give me the same decimal, they'd be considered proportional. Okay? Those methods are all great, but they're not going to work all the time. So for example, if I was trying to figure out if a 4-to-7 ratio was equivalent or proportional to a 7-to-10 ratio, can I simplify either of those fractions? No, so simplifying doesn't work. Is there a common multiplier? 7 times some whole number gives me 10. No. So that strategy doesn't work either. So you'll see how for some of them, not all of these strategies work. The one strategy that we're going to focus on today that's going to work for every single proportion is this idea of cross products. Okay, so that's where we're going to focus today. So what we're going to do for cross products, basically cross products tells us that if 2 ratios are proportional, they're cross products, so cross meaning the diagonal, and product is a buzzword for what operation?
I found this on the web.
I have to do it again. Multiplication. So when I multiply on the diagonal, they should equal the same thing, okay? So, for example, this one, 10 times 6 gives me what?
60.
So the product there is 60. What about 15 times 4?
60.
Also 60. Because both of these have the same cross product on the diagonal, they multiply to the same thing. These two ratios are proportional. So a 15 to 10 ratio is proportional to a 6 to 4 ratio. What about 14 to 10 and 21 to 3? Well, let's start here. 21 times 10 is 210. What about 14 times 3? Is it going to be 210? Yeah, who really cares what it's going to be, right? It's not going to be 210. I should be able to use some quick estimation to know that 14 times 3 is not going to be in the 200s. So I honestly, at this point, don't even care what it's going to be. What I do know is that those two ratios are not proportional because their cross products are not the same. So a 14 to 10 ratio is not equivalent to 21 to 3. Okay? All right, in your notebook, whether it's in like the margin next to your proportions notes if you've got space, or honestly a lot of people today have just chosen to flip the page and use the next blank page as their workspace. I want you to take a minute or two to check these two sets of ratios and tell me, using cross products, are they proportional or not? So this is where you're going to want to use your calculator. One thing before you start, some people today have gotten confused because they're like, wait a second, how come now all of a sudden we're allowed to use decimals in fractions? Well, even though this is in fraction form, these aren't true fractions, they are ratios. You are always allowed to put decimals in ratios. Don't get confused and think that it's just a fraction, okay? So I'm going to give you about 2 minutes here. Check your cross products to tell me if these two sets are proportional or not. All right, let's compare. What about for the first one? Who can give me one of your cross products? Millie? All right, so this one is 4.2. What about your second cross products? Clinic. It's in the clinic. Gabrielle. 12.6. Gabriella tells us this one's 12.6. Are those proportional ratios? No, our cross products are different, so those are not proportional. What about the second one? Give me one of your cross products there. Evelyn. Okay, 16 times 3 is 48. What about 8 times 6? Hopefully we didn't use our calculator for this one. Haley? 48. So are those two ratios proportional? Yes, because their cross products are the same. We would say 8 to 16 is equivalent to 3 to 6. Somebody in my last class actually pointed out, oh, I actually knew that differently because I knew that both of those simplified to a 1/2 or a 1-to-2 ratio. So real quick looking at that, 8 over 16 is a half, 3 over 6 is a half. That's one of the strategies we talked about, which is great that you recognize that. I want you to focus on cross products today so you understand the process, okay? I will say the biggest thing that people have been having a hard time with today is the idea of showing your work. A lot of people are like, oh, the numbers, I can do the numbers in my head when we get to this next step. I don't need to show my work. I'm giving you, especially on the homework, a lot of easier numbers to work with. That way you might be able to start asking yourself, does this answer make sense? I want you showing every step of your work so that you can make sure that you understand the process and you've got the process down, okay? So with that said, let's look at what happens here. So most of the time with proportions, you're not going to be checking to see if they're equivalent. You're basically going to be looking for a missing piece. So for example, here I have m over 36, or m to 36, equals 10 to 15. So I'm basically asking, a 10 to 15 ratio is equivalent to a what to 36? And I'm using that letter M. Does anyone know what it's called when we use letters in math? It's a word that starts with a V. Reese, just kidding. Ellie? Just kidding also.
What's the second letter?
A, V-A.
Algebra? Oh, no.
Algebra doesn't start with a V.
Could be silent.
Variable. When we use a letter in math, it's called a variable. So let me ask you this. What letter has represented a math symbol up until this year? Millie? X. What has X meant to you up until now? Multiplication. Or if you're reading a treasure map, Hank, yes, X marks the spot, right? In math up until now, though, X has meant multiply. This year you need to get rid of using x for multiplication, because all throughout the year we're going to be using x as a variable, an unknown number. And if you're using it for a variable and for multiplication, you're going to confuse yourself a lot. So instead of the x, we're going to be using a dot to represent multiplication. And you'll see me doing that today, so just start getting in the habit. It's going to be a habit that you have to break. The more we do it, the more you'll get used to it. Okay, so right now I want you to look up front, and I'm going to show you exactly how we're going to solve when we have a variable. So we're still using cross products, but it's just going to be a little bit different. So I always like to start with my cross product that has the variable in it and write that out first. So I'm just going to write that as 15 times m. 15 times some unknown number, and that needs to equal my other diagonal or my other cross product, which is 36 times 10. You with me so far? So all I've done is taken my two diagonals and set them equal to each other. I still don't know what 15 times m is, so I'm going to just bring that down. Kind of like if you were solving order of operations and you're working your way down the page, right? What is 36 times 10? 360. So I know that 15 times some unknown number has to equal 360. Okay, there's an easier way than guess and check to solve this. So instead of saying, well, is it 15 times 10? Is it 15 times 12? Is it 15 times 15? How would I work backwards and solve this? Instead of saying 15 times what gives me 360, what's the opposite of that, Scarlett?
360 divided by 15.
Yes.
I have to go.
Okay. I'm recording. Say it one more time.
360 divided by 15.
Yes, so Scarlett told us that instead of doing guess and check, the opposite of multiplying is going to be to divide. So we're going to take what it equals, 360, and we're just going to divide by whatever number is attached to the variable. And you can use your calculator for that step. 360 divided by 15 gives me what? 24. So what that tells me is that a 24 to 36 ratio is equivalent to a 10 to 15 ratio. Okay? That one I asked you to just watch. A couple of you wrote it down, which is fine. These next two, I want you to put in your notebook so you've got two examples to look at with work. Okay? So go ahead and start by copying this one down somewhere in your notebook. Go ahead and copy this one down in your notebook so that we've got an example to look at. We've got a over 10 equals 11 to 14. And make sure you're copying every piece of work that I write down in red, you want to copy down into your notebook, okay, so that you've got all the work to show for it. So we're going to start, I always like to start with my side that's got the variable in it, okay. So I'm going to say 14 times a, and that's going to be equal to my other cross product, 10 times 11. So all I did for my first line of work is take my two diagonals and set them equal to each other. Now I'm going to simplify or do this math problem. What is 10 times 11?
10 times 11.
Haley's got it. 110. Oops. So 14 times a is equal to 110. Scarlett told us this step last time. What am I going to do to get my final piece of information? Instead of doing 14 times and doing guess and check, what's the opposite of multiplication that's going to help me solve this? Division. I'm going to divide by 14. So 110 divided by 14. Eight, 5, 7, 1, something, something, something. Okay. We'll round to the 100th place this year. So 100th place is this one with the 5. Does 7 tell us to round up or stay the same?
Round up.
Round up. So we're going to say A is equal to 7.86 here.
What? Wait, oh.
So to get this long decimal, I did 110 divided by 14 in my calculator. Gave me this, and I just rounded it to 7.86. Okay, let's try one more in your notebooks. Do you have all that work down? Are we good on that one?
Hold on.
Okay. Next one is 6 over 14 equals 5 over n. 6 over 14 equals 5 over n. And once you have that copied down, raise your hand if you feel like you could tell me what the first line of work is going to look like here. Millie, you feeling good about that?
Yes, you put down 6 times n.
Good. And what's that equal to?
6
So 6 times n, what's going to be on the other side?
on the other side. 14, which is equal to 14 times.
Good, which is equal to 14 times 5. So Millie just took her 2 diagonals and set them equal to each other. 6 times n equals 14 times 5. Which, was it Evelyn? Evelyn told us 14 times 5 is going to be 70. So we're going to say 6 times n equals 70. And then what's our last step? Instead of multiplying 6 by something and doing guess and check, which is going to take you forever because it's another decimal answer, what's the faster way to solve that? Look back at your last step from before. When we had 14 times a equals 110, what did we do? And do the same thing over here. Maddie, give it a guess. By what? So over here, we divided by the 14 that was being multiplied by the a. So what do you think we're going to divide by over here? The number that's attached to your a, so your 6. So we're going to divide 70 divided by 6 in your calculator. Ellie?
So 11.
Point. Yeah, 11.6 repeating. And we show that that decimal repeats by drawing that line over it, which is just called a hat. And putting the hat on it. Now, some people have said, no, my calculator, it was 0.6666667. Yeah, your calculator is smart, and it actually rounds for place value. So when it ran out of space, it just rounded in its last place. It is a repeating decimal there. Okay? So for homework tonight, you are going to do 12 practice problems with cross products. I'm going to pass out that sheet in a second. And I want you to use this process, showing every step, because I want you to get in the habit of showing these two sides are equal to each other. So you're going to use your notes as an example to try to solve these. Haley.